This is for those of you that are missing the second part of 9.6 or want some extra help. Going back to this. Okay, so Joey can travel 120 miles in the same time that it takes Trevin to travel 93. If Joey travels at 15 miles per hour faster than Trevin, find the speed that each person is traveling at. Okay, we have to remember that distance is equal to the rate of speed times the time, or the rate equals the distance divided by the time. Now we know that Joey make a little chart, distance, time, rate. Joey can go a distance of 120 miles at the same time it takes Trevin to travel 93. So under the distance, I put their distances, but as far as the time goes, we don't know what that time is. We just know that it is the same time, so I'm going to put t for each of these. The rate is equal to the distance over time. So for Joey, it would be 120 miles divided by whatever that time is. And then for Trevin, it would be 93 miles divided by whatever that time is. Next sentence, if Joey travels 15 miles per hour faster than Trevin. So what we're saying is that Trevin's speed plus 15 miles per hour equals Joey's speed. Find the speed that each person is traveling at. So Trevin's speed or rate was 93 over t. So I'm going to say 93 over t plus 15 equals Joey's speed, which was 120 over t. Next thing I'm going to do is take this over to the other side, that fraction. So I can get the 15 by itself. So 15 is equal to 120t over t minus 93 over t. Keep moving here. 15 is equal to 27 over t. Now, I have a fraction over on the right, I don't have a fraction on the left, so let me put that over 1. 15 over 1. Now we'll cross multiply, we get 15t equals 27. T is equal to 27 over 15, which equals 1.8. Now what we'll do is take each of these rates to find the actual speed. 120 divided by 1.8 hours for the t. Do the same thing for Trevin's speed. 93 divided by 1.8. You will get 66.6 repeating miles per hour for Joey and 51.6 repeating miles per hour for Trevin. Christy can bike 12 miles in the same time it takes Alex to bike 9 miles. Christy bikes 4 miles per hour faster than Alex. Find each of their biking rates. Same thing. Okay, so remember, rate equals distance over time. Distance, time, rate. We have Christy. We have Alex. Christy can bike 12 miles, that's the distance. Same time, so put a T as Alex, so put a T for both of those. Alex does 9 miles in that time. The rate for Christy would be distance over time, 12 over T. Alex, 9 over T. You know that Christy bikes 4 miles per hour faster than Alex. So you can write Alex plus 4 miles per hour equals Christy. Alex is 9 over T. plus 4 will equal Christy 12 over t. Move that 9 over t to the other side so you're subtracting fractions. And you should get 3 over t equals 4. Let's do over 1. Cross multiply. I'm going to keep it moving over here. 4t equals 3. T equals 3/4. Now we're going to plug this in for the t in the right. 12 divided by our 3/4, or 0.75, and 9 divided by 0.75 equals 16 miles per hour for Christy and 12 miles per hour for Alex. Jim and Alberto have to paint 6,000 square feet of hallway in an office building. Alberto works twice as fast as Jim, and working together they complete the job in 15 hours. How long would it take each of them working alone? Okay. So, what we know is that there are 6,000 square feet total, and Alberto works twice as fast as Jim. So the time that Jim would take would be twice as long as Alberto. So what I would say is that the time for Jim equals 2 times the time of Alberto. So it might be better to make a chart again. Alberto, Jim, distance, time, rate. Alright, so we aren't talking about distance really, but they still have to do a certain amount of work, and that certain amount of work would be 6,000 square feet. So we have Alberto having to cover a distance of 6,000. They both have to cover a distance of 6,000. The time for Alberto would be half that of Jim, or Jim we can say is 2 times Alberto. If we give Alberto time t, Jim would be twice that because he works twice as slow, or Alberto works twice as fast. So each of their rates, in the case of Alberto, it would be 6,000 divided by t, that time if he was all by himself, and then Jim, it would be 6,000 divided by 2t if he was all by himself. But they're working together. So what we're going to do is put these rates together, and we know that they have to do it in 15 hours. So we are saying that Alberto's time, or rate, 6,000 over t, plus Jim's rate, have to work out to be equal to 6,000 over 15, because together they have the rate of 6,000 square feet in 15 hours. How long would they each of them take working alone? Well, that would be t. That's what we're solving for. So what we need to do is realize what we have to do to these fractions on the left side so that we can add them. What you realize is that this fraction right here has 2t, while this one has just a t. So the fraction on the right here has a 2, while the fraction on the left doesn't. So I'm going to multiply both the top and the bottom by 2. So that you're taking 6,000 times 2, which is 12,000, plus another 6,000, all divided by 2t. So you'll have 18,000 divided by 2t equals 6,000 divided by 15. Cross multiply. 15 times 18,000 equals 27,000. And then 6,000 times 2t is 12,000 t. Divide by 12,000, you get a time of 22.5 hours. T represented the time for Alberto. And we know that Jim would take twice as long. 2 times 22.5 equals 45 hours. For Jim. Tim can stuff envelopes 3 times as fast as his daughter Georgia. They have to stuff 5,000 envelopes for a fundraiser working together. They can complete the job in 4 hours. How many hours would it take each of them working alone? Okay, so this is another problem that's very similar to the last one. So what we're going to do is remember that rate equals distance over time, or just an amount over time. In this case, we're going to have envelopes. The number of envelopes in place of the distance. So let's make a distance, time, rate. We have Tim, Georgia, so if Tim was working alone, he'd have to stuff 5,000 envelopes in a certain time. And then if Georgia was working alone, she'd have to stuff 5,000 envelopes in a time that is 3 times as long as her father. If he stuffs them 3 times as fast, she's 3 times as slow, taking 3 times as long. Then the rate of Tim by himself would be 5,000 over t. The rate of Georgia by herself would be 5,000 divided by 3t. But together they have to create a rate of 5,000 in 4 hours. So together the rates work together. Now you ask yourself, what does the fraction on the right here have that this one doesn't, or the bottom? It has a 3, so I'm going to multiply both the top and the bottom by 3. So you'll have 15,000 plus another 5,000 all over 3t. Keep on working over here. We have really 20,000 over 3t equals 5,000 over 4. Cross multiply. You get 80,000 equals 15,000 t. Divide by 15,000. You get a time of 5.3. And that would be for just Tim. So Tim equals 5.3 repeating hours alone. Georgia equals 3 times that. which is 16 hours. Suppose Maria can stuff envelopes twice as fast as her friend Paco. Together they can stuff 6,750 envelopes in 4.5 hours. How long would it take each of them working alone? This is the same type of problem. Mixed rate. So I'm going to make this a little bit quicker, knowing that Maria can stuff them twice as fast as her friend Paco. I'm going to go straight to the rates. If Maria stuffs alone 6,500 or 6,750 in a certain time, it would take Paco twice as long to do it. And then those two added together, those two rates, 2t equals the total amount of envelopes being able to be stuffed in 4.5 hours. Multiply both the top and the bottom by 2 over here. So that 2t is the new denominator, and you have 13,500 plus cross multiply after you add these two together, and you will get 4.5 times this numerator equals 9,100 or 91,125 equals 13,500 t equals 6.75. So that would be the time for Maria, and then it would be twice as long for Paco. So Paco, 2 times that equals 13.5 hours. Suppose Adrian can weed the garden twice as fast as his son Philip. Together they can weed the garden in 3 hours. How long would it take each of them working alone? Same type of problem. Anita and Fran have volunteered to contact every member of the organization by phone to inform them of an upcoming event. Fran can complete the calls in 6 days if she works alone. Anita can complete them in 4 days if she works alone. How long will they take to complete the calls working together? Alright, so this is another one, but it's kind of the opposite of what we just did. Before, we didn't know how long it took them individually, so we had to figure this out. And we did know how long it took them to work together. And now this time, we're trying to figure out how long they take to work together, while we already know what their alone times would be. So we have Anita and Fran volunteer to contact every member of the organization by phone. Okay, complete this. So 6 days, so she works alone. 4 days. How long will it take to complete the calls working together? Okay, let's say that we have Fran, and she has to do, let's say, 100 calls, and it takes her 6 days to do it. So 100 calls in 6 days would be her rate. Anita has to complete, let's say, the same 100 in 4 days. how long will it take them to complete the calls working together. So if they're working together side by side on a phone, so we take Fran's plus Anita's equals the same 100 calls divided by, we don't know their time. What I'm going to do, for the tops, or actually for these two fractions on the left, I'm going to multiply by 3 and by 2 so that they both have a denominator of 12. 4 times 3 is 12, and then that would be 300 plus another 200, which is 500, equals 100 divided by x. Cross multiply. 1200 equals 500x. X equals 12 over 5, which is 2.4. So it takes them 2.4 days